At the end of this video, you will be able to answer the following questions. What is theoretical yield? You will be also able to answer what is actual yield. And if you watch the video at the end, you will also able to calculate percentage yield. Now let us first discuss theoretical yield. So we are discussing something called theoretical yield. As name suggests, something of theory. So this theoretical yield has something to do with the theory. It is not practical. It is only theoretical. This is not practical. Let us say I have a reaction A plus 2B, and that gives you 3 mole of C. And if I take 5 mole of B, what is the mole of C that will be formed? So one can say 2 mole of B will gives you 3 mole of C. So corresponding one can find 5 mole of B will give. So let me write 2 mole of B produces 3 mole of C. So 1 mole of B will basically produce 3 by 2 mole of C. Similarly, 5 mole of B will produce 3 by 2 into 5, that is 7.5 mole of C. So if you calculate the product C using this equation, and that is 7.5 mole of C. This kind of yield that can be calculated on paper, that can be calculated using the theoretical equation, that can be calculated using the balance equation, is called theoretical yield. So what is the meaning of theoretical yield? So theoretical yield is the yield that can be calculated using the balanced stoichiometric equation. So theoretical yield is the yield that can be calculated using balanced equation on paper. Are you getting or not? This is your theoretical yield. Now let us discuss actual yield. Now this actual yield is basically practical. This really happens. So let us say if you have the same reaction A plus 2B, that gives you 3C. This gives you 3C. And now let us say if you take 5 mole of B. So if you take 5 mole of B, you will expect that one can get 7.5 mole of C. But things is not so easy. If you do this reaction, some of the B or some of the A might be lost due to some practical reason. So you are thinking you will mix A and B and you will get C. This is the thing you are thinking. But in industry this does not happen. There are some side reaction also taking place, that A plus B reacting, and they are forming some another compound D. So this is the side reaction. So due to the some side reaction, A plus B forms some another product. We can call this as a byproduct. So if this byproduct is formed, so this means some of the A plus B is used to form D. So this means there will be some less amount of C that will be formed. That is the actual yield. So in industry, I will get less amount of C that is calculated from the balanced equation, and this is called actual yield. So what is actual yield? So actual yield is the yield that can be obtained in the industry. Is the yield that can be obtained in the industry. Are you getting? Let us say for this reaction, from experiment one finds that only 5 mole of C is formed. So 5 mole of C actually forms. So in this case actual yield is 5 mole of C. So in this case I can say actual yield is 5 mole of C. Now the next is percentage yield. And this you can easily understand. What is the percentage yield? That is, you are expecting that one can expect 7.5 mole of C, but you are getting only 5 mole of C from industry. You are getting only 5 mole of C. This means you are getting less. But how many percent you are getting? That is, we define percentage yield is equals to actual yield divided by theoretical yield multiplied by 100. For our case, for this problem, actual yield is 5 mole, theoretical yield one can expect 7.5 mole, and this multiplied by 100, so this will be 5 divided by 75. So you can calculate this one. So let us calculate this one. 5 divided by 7.5, 5 divided by 7.5, and this is equals to and multiplied by 100, so around this is around 66.66%. So this is around 66.6%. So actual yield is only 66%. That is the percentage yield. Now let us say I have a reaction. A gives B and B gives C. For this reaction, percentage yield, let us say 80%. And for this reaction, percentage yield is 70%. And I start, and the balance reaction I give you, let us say, let me give you the reaction, this reaction 1, and this reaction 2. So A gives you B and B gives you C, and things are very simple. 1 mole of A reacts and gives you 1 mole of B, 1 mole of B reacts and gives you 1 mole of C. Somehow it gives reaction gives something like this kind of. So this is a simple reaction I'm writing. So let us say I start with 5 mole of A. So if I start with 5 mole of A, what is the mole of B I will get? Because actually I will expect, that is by theory, if I say theory, 1 mole gives you 1 mole, so 5 mole give you 5 mole. But the yield is 80% only. So yield is 80%. So now you see we can write a formula. Actual yield is percentage yield into theoretical yield. Are you getting or not? And divided by 100. So we can write, so the same formula can also be written as actual yield is equals to percentage yield into theoretical yield. So let me write percentage yield into theoretical yield divided by 100. So in this case, actual yield is equals to percentage yield. What is the percentage yield? 80%. So for first reaction, we have 80% is the percentage yield. So 80 multiplied by theoretical yield. So what is the theoretical yield one can expect? 5 mole will give you 5 mole. So that is the theoretical yield, 5 mole divided by 100. So you will have 80 into 5 divided by 100. That is the 4 mole of B. Now this is the 4 mole of B. So now you have 4 mole of B. Now if you go in this reaction, that is only 70% yield. What is the mole of C? So mole of C we can find using the same idea, that is the actual yield, percentage yield multiplied by theoretical yield. So 4 mole will give you 4 mole. So 4 divided by 100. So what is the final answer? So this is 2.8 mole. So you see, finally you are getting only 2.8 mole. So this you can always find. You see, if you have a reaction, A gives you B and B gives you C. Initially you have reaction 1 coefficient, here also you have 1, here you also have 1. Now this reaction is 80%, here you have 70%. You can directly find mole of product. Let us say here you have 5 mole. So C you can directly find 5 into 80 by 100 into 70 by 100. So if you do this calculation, I think you can do this one. So let me do. So 5 into zero point 0.8 into 0.7. So this is 0.8 and this is 0.7. So this is 5 into zero point 0.8 into 0.7. So this is equals to 2.8. So this means if I have a reaction in series, percentage yield gets multiplied. In this case, I am getting same product as I am getting here. So if I have a reaction in series, percentage yield gets multiplied. So this is one of the important concept I have. If I have reaction, so this kind of reaction A gives B gives C are called series reaction. Reaction in series percentage yield gets multiplied. So if I ask, I have a reaction A to B, B to C and C to D, this is 90% yield, this is also 90% yield, this is also 90% yield. Let us say D to E, also 90% yield. What is the equivalent percentage yield? So I ask, what is equivalent percentage yield? So as I have said earlier, so equivalent percentage yield gets multiplied. So this is 90 by 100 multiplied by 90 by 100 multiplied by 90 by 100. So 4 times I have to multiply by 90 by 100. So we can calculate this value. So 0.94 times 0.9 into 0.9 into 0.9 into 0.9 and one more time into 0.9. So this is 0.59%. So multiplied by 100 also we have to have. So if I find percentage yield, I have to multiply by 100 also. So this is 59%. So one important point, even though all reactions are having very good percentage yield, 90%, 90%, 90%, 90%, but the theoretical actual percentage yield is only 59%. So you see, it reduces a lot. So in this case, I say, even though each reaction each reaction has high percentage yield, overall reaction has a very low percentage yield. Sometimes this can be useful. Let us say I have these things are very cheap, that this cost very less. So A, B, C, D cost very less, but E cost very high. So in these cases, this kind of reaction is very useful, because even though the percentage of E is very less, but this is so costly, so we can use this kind of reaction. So this kind of reaction is useful if the final product is very costly. So this kind of series reaction is useful when final product is very important. Maybe it money wise, or it is value wise. Maybe it is money wise, or it may be its significance, that is value wise. So we have discussed in this lecture what is the theoretical yield, that is the yield calculated from the balanced equation. We discuss actual yield, the yield that is calculated in the industry, that is the yield that we obtained in the industry. And the last we said what is the percentage yield, that is actual yield divided by theoretical yield multiplied by 100. And then we have said if I have a series reaction, overall yield is simply multiplied. Now some cases in series reaction, if the final product is very important, even though reaction final yield percentage is very low, this kind of series reaction becomes important.